looking at 10.5 other angle relationships. Okay, we've talked about central angles and interpreted angles. If a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its interpreted arc. We're going to talk about that. If two chords intersect in the interior of a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs interpreted by the angle and its vertical angle. 10.13. If a tangent and a secant, two tangents, or two secants intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the interpreted arcs. Okay, so let's draw some pictures for these. First, 10.11. If a tangent and a chord, okay, so we've got a circle. We know the tangent hits at one point on the outside, and we've got a chord. Okay, the chord can come from anywhere. If they intersect at a point on the circle, then the measure of each angle formed is 1/2 the measure of its interpreted arc. So remember, its interpreted arc is here, so those measures are 1/2 the arc. So if we know what this measure is, we know half of it is the angle between these two. And we'll do examples of it, so don't make much. Because I know my lovely drawings are not lovely, we'll just say it that way. Okay, if two chords intersect in the center of a circle, okay, then the measure of each angle is 1/2 the sum of the measure of the arcs interpreted by the angle and its vertical angle. If two chords intersect in the interior, so not in the center, inside the circle, then the measure of each angle, so each of these angles, is 1/2 the sum of the measures of the interpreted arc and its vertical angle. So this angle right here plus this angle right here divided by 2 equals that. So I'm just going to call it A, B, and we're going to equal C, the angle. A plus B divided by 2 equals C. All right, theorem 10.13. If a tangent and a secant, or two tangents, or two secants, intersect in the exterior of a circle, so let's look at two tangents, meet in the exterior circle, then the measure of the angle formed is 1/2 the difference of the sum of the interpreted arcs. So we've got, I'm going to label this again, A, B, C. So is 1/2 the difference, so A minus, or B minus A divided by 2 equals C for this. And we'll do some examples, so it'll make more sense. I just want you to have a general understanding.
So the first one is what?
The first one is 1/2 of the angle. We're going to do ones just like that right now, so it can make more sense. Okay, the intersection of chords and tangents. So this is all theorem 10.11. We know that this is y, this is x, and this is 156. Okay, so Smurfy needs a calculator, so I keep messing up my basic math skills. So I think it's called being too tired. All right, so let's figure this out. What's half of 156?
78.
So x would be 78.
You actually
Yes, he did. And I didn't listen to you, Elijah. All right. What is 360 minus 156? 204. Okay, and then we say what's half of 204. Then we get y equals 102. Okay? This is really important. There's a lot of different weird little things like this for these circles, so you need to make sure you write them down. I took 156, this arc right here is 156, half of that gives me that angle. Okay, you ready for B?
Yep.
We want to know what x is, and we have that the angle is 90. So how do we go backwards?
362 divided by 2.
Or 90 times 2. So x equals 180. Do you get how we're working backwards?
Yeah, and I got a question. If you lie on A,
I said 156 minus 360 is 204. Half of 204 is 1. Another question? I saw somebody's hand up. We're okay now?
So it's 360 minus 156.
gives me 204, and then half of 204 is y. Gotta let me know if I'm going too fast. All right, we've got 2x, and we've got x, and we've got to find the angle y and the angle z.
What is that? 180, about 70.
180 because isn't it like that inside angle you multiplied by 2?
This inside angle right here,
No, the other one.
b, yes.
I don't even know how to do that.
156 divided by 2. We got x. Okay, that's the rule. It's 10.11. Right there. That's the rule. Okay, we know that exterior angles of a circle add up to be 360. So 156 minus 360 minus 156 gives us 204. Half of 204 is 102. This is all for A. Okay. B. This is 90. I know half of x is 90, so how am I going to work the other way? I'm going to multiply it by 2. So I get 180. So far, so good? Good. This one looks weird. We've got 2x and x, we've got y and z. So we don't really have any numbers here. But what do these two angles have to add up to be? 180. It forms a straight line, right? So, and I just moved it. Okay. 2x plus x equals 180. So 3x equals 180. So x equals 60. I'm positive. So this angle's 60. 60 times 2 is 120. Okay. Twice 120 is 240. And twice 60 is 120. So that's y, that's z, that's x, and we've got 2x.
Y equals 240.
Uh-huh.
And then Z equals 120.
Yes. Did I lose some people? I did that pretty fast. Yeah, Brianna? I know. See how it forms a straight line?
Oh,
I'm looking for these angles right there. So I know it has to add up to 180. So that's the first step. 2x plus x equals 180. Solve for x, and it equals 60. Okay, 2x plus x equals 180, you get 60. So I plug 60 back in for x. Well, I know twice x is z. So I know that's 120. 2 times 60 is 120. 120 times 2 gives me 240. Feeling okay? I'm going to move on to do example 2, 2 intersecting chords, which is 10, 12. Okay. I've got, this is 135. This is 100. And this arc is x. I know if two chords intersect in the interior of a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs interpreted by the angle and its vertical angle.
So it's 135.
So let's look at this again. The measure of each angle is half the sum. So we know we're going to divide it by 2. The sum means we're going to add. The measure of the interpreted arc,
It's not 135.
okay, 135, I actually think it's x, is 1/2 the sum of the measure of its arc, interpreted by the angle, and the vertical angle. So now we have to solve. So we're going to multiply both sides by 2.
Why is that one?
So wait, no, say we said 80.
270. X plus, hold on. I hear you, Nathan. I'm not ignoring you. I just want to finish it.
How do you do 270?
oh,
So I multiply both sides by 2. These cancel. And then I subtract 100, and I get x equals 170. So, Nathan, what I think it's saying...
Well, it says A plus B on the
Yeah, I think that's wrong.
I think it is wrong.
Because it's 1/2 the sum of the measure of the arc interpreted, which would be the arc interpreted, and its vertical angle. So these are vertical angles divided by 2.
So it's going to be like X plus 135.
Yeah. So let's try B and see if it makes more sense when we do this one. So we're trying to find x. So if we get its angle plus its interpreted arc, which would be 110, divided by 2 should equal 30. 2 times 30 is 60 equals x plus 110. Subtract 110 from both sides. Am I doing this right? I feel like I'm not too, because I feel like there's no such thing as a negative angle.
Well, there wouldn't be though, because
I did it the way
wait,
that.
so you wouldn't have a negative angle because either way you go, like one way or another, it's going to be positive. Because you can't go backwards on this one.
This right here. I did A and I did that correctly. I did x plus 135.
So what am I putting? I'm putting something in the wrong order.
At 65. At A. I know that's not right.
So,
Well, what you said on this
Ah.
it'd be the two outsides.
yes.
See, that's what I did at first.
All right, let's back up. I knew this didn't make sense.
It'd be 30 plus 110 equals x.
Okay. So, and 5, 4, 3, 2, 1. Let's try this again. Let's see if I did A right the first time. We know this is 100, this is x, this is 135. This is why I do my notes in advance, and I should use them. Okay. So I have 135 plus x divided by 2 equals 100. That makes so much more sense.
Yeah, that's the way it is.
Okay, so I get 200 equals 135 plus x, subtract 135, and I get x equals 65. Okay. So much. Okay, now I'm going to explain b, because I think I got it.
200 or 100?
This says 100, and then I multiply both sides times 2,
Below it.
and so I got 200. Okay. So, for B, I've got this outside part right here is 110. I have this inside is x, and this is 30. So, we're going to take the arcs and we add them together. So, it's 110 plus 30 divided by 2 gives me x. So, that is just 70. So we know that we add the arcs, divide by 2, that gives us the angle. Okay? So you might want to make sure when you write down your postulates and theorems, draw a picture, and write out kind of the formula. Arc plus arc divided by 2 equals angle. That's going to be helpful.
So
Okay.
the biggest arc be
Yeah. Arc plus arc divided by 2 equals angle. Okay, so we get 2x here. We get x here, we get 45. Does somebody want to try this? Setting this up?
2x plus x.
Okay, let's raise your hand. Let's raise your hand. Cody?
2x plus x divided by 2.
You said it correct and I wrote it down wrong. Okay. So this is the most common mistake you guys make with your algebra. What do I do here before that? Divide by 2, multiply both sides by 2. And then you no longer have a fraction. And then 3x, combine like terms. And then divide, x equals 30. Okay, don't forget to get rid of that 2 on the bottom by multiplying both sides. Okay, last theorem, and then we've got some mixed ones to do.
What did you say that one theorem was? For like that angle plus or arc plus.
That is theorem 10.12.
What was it?
Arc plus arc divided by 2 equals angle. Okay, this is theorem 1013. We've got, we're going to try to find angle 1. We've got the arc here is 43. We've got the arc here is 92. Okay? So if you've got an exterior angle, those are for interior angles. This one is only slightly different. We're going to have arc minus arc divided by 2 equals angle.